Hi guys, we're going to start Unit 7 today, which will focus on ionic bonding in metals. We have been focused on covalent bonding, where electrons are being shared between non-metal atoms. Now we're going to be looking at metals and non-metals gaining and losing electrons to form ions, and then those ions bonding together to make ionic compounds. So we're going to start with ion formation. Chemical bonds form when atoms share electrons or when positive and negative ions attract each other. So it's a different type of bonding than covalent bonding. It's an opposites attract scenario, whereas covalent bonding is atoms overlapping and sharing their electrons. Now, valence electrons are involved in both types of bonding, so we are going to be focusing still on valence electrons. All right, positive ions. They form when a metal atom loses one or more valence electrons. We call positive ions cations. And the electrons are lost in order to achieve the valence electron configuration of a noble gas and to follow the octet rule. So let's look at some examples. Okay, so if we start with just a sodium atom, the electron configuration would be 1s2, 2s2, 2p6, 3s1. So sodium has one valence electron. Well, if it loses that one valence electron, it will turn into a sodium ion with a +1 charge, and now its valence electron configuration is the same as a noble gas. It's the same as neon. So it has now followed the octet rule. Calcium has two valence electrons in the 4s2 orbital. If it loses those two, it will become a calcium ion with a +2 charge, and it'll have the same configuration as argon. Aluminum has three valence electrons. If it loses three, it'll have a +3 charge and the same configuration as neon. Okay, so anything in the same group as sodium, so all the alkali metals have one valence electron, they'll have a +1 charge. Alkaline earth metals, two valence electrons, +2 charge. And then aluminum kind of stands alone over there in group 13 with three valence electrons. Now, what if your metal is a transition metal? Well, those d orbitals give it some special things we have to look at. So because they have electrons in d orbitals, they can form ions with multiple charges. For example, copper can form either a +1 or a +2 charge. You can't tell from looking at the periodic table. You have to be given the charge, and the name of the ion will include a Roman numeral telling you what the charge is. So for example, copper +1 is called copper Roman numeral 1. Okay, negative ions. A negatively charged ion forms when a non-metal gains electrons to achieve an octet. We call it an anion. Now the name of this ion changes. It ends with "ide." The metal ion stays the same, so sodium becomes a sodium ion, but the anion changes its name to have "ide." For example, chlorine has the valence electron configuration 3s2, 3p5. It has 7 valence electrons, so it gains 1 to have 8, just like argon, and we change the ending of the name. So chlorine becomes a chloride ion with a -1 charge. Oxygen has 6 valence electrons, so it gains 2 to have 8. We change the ending, so oxygen gains 2 electrons and becomes an oxide ion with a -2 charge. So if you look at the periodic table, all of the halogens, fluorine, chlorine, bromine, iodine, they all have 7 valence electrons. They'll all end up with a -1 charge. The group that starts with oxygen has 6 valence electrons. They'll all end up with a -2 charge. The group that starts with nitrogen, they have 5, so they will end up with a -3 charge. Carbon's group, they don't really bond as ions. Carbon bonds covalently, so you're not really going to deal with those. So most of the time you'll have either -1, -2, -3 charge for the anions.